Hello, academic stars in the house. Welcome to CEX Academy once more. If you are not one of the academic stars, what are you waiting for? Just subscribe to the channel and become one of the stars. So with all this said, let us look at our topic of today, and that is integration of tangent and secant with odd powers. And this is the last video in our series. We looked at several videos of this same topic of odd powers, and the link of those videos are in the description of this video. If you need to watch them after finishing this video, you can go ahead and also watch those parts of this series. Now, with all this said, if you're excited just like me, come closer and let's dive into the video. So the first thing we have to do is to make sure that we split the secant cube x into two parts such that we obtain a square out of it. So let's rewrite our question down here, and we have the integral of tangent with angle x secant cube with also angle x. This will be equal to the integral of tangent x times. Now here we're splitting our secant. So the first one is secant x and secant to the power of 2 of also x with respect to x. Here, this secant is to the power 1, and since we're multiplying with the same basis, we add the powers back to 3. Now, next thing here, we can rearrange such that we start with secant and followed by tangents, because here is a little bit confusing, and when we shall also be differentiating, we shall look at it clearly if we arrange starting with secant. So let's do that in our next step here, where we will start with this secant in the middle, and we have secant angle x times tangent also angle x. So times our secant, that is squared with angle x with respect to x. After reaching to this stage, then we employ u-substitution. So how can this u-substitution comes in? Now the next thing is to take our secant square, and we just remove the secant itself of that angle x to be equivalent to our u. Now here, the derivative of secant is secant x tangent also of x, and here is with respect to x. So this is equivalent to the derivative of u is 1 with respect to u. Now let's make the x the subject. So we have here the x will be equivalent to now du over secant of x and also tan x. So at this stage, we are free to make our u substitution here because we've already let it up there. Now we'll have integral of course the first two ratios. We just need to write them like that, and we have secant x times tangent of x. So this time the one which is squared can be replaced by u, and also we have to square the u because the secant was squared. So our dx this time is du, so we can place there du all over secant x and tangent of also x. Now we can go on and cross secant x tan x with this denominator secant x tan x. And our only thing here is to rewrite u square with respect to u. Now next is to integrate that u with respect to u, and we obtain 1/3 of u exponent 3 plus the constant of integration. And finally, we just need to make our substitution back. Therefore, the integral of tan x secant x secant³ x with respect to x will be equivalent to 1/3, and we replace our u with secant, but this time is raised to power 3 of the same angle x plus the constant of integration. So that becomes our solution for this question. In case of any question or any point of clarification, you can go ahead and leave it in the comment section. I will get back to you. So next, let's look at the second part of this question, which is talking about the integral of secant 2x tan³ 2x. So let's copy our question down here, and we also do the same work. In this part B of the question, we're given the integral of secant 2x times tan³ 2x with respect to x. So what we can do also is to split this to obtain our square term. So we have the integral of secant 2x times tan, also with the angle of 2x, again times another tangent. Now this time it is squared with the same angle with respect to x. Now, having written this, this is already in the order of the integral of the secant, but what we have here is tangent. So in order for us to get something similar to the first two terms, we have to write tangent square 2x in terms of secant. So let's do that, and we replace that. So the next one here, we can maybe get a different color and replace here that, okay, when we have secant square with an angle of 2x, this can be given the same as tangent, also square with the same angle 2x plus 1. So here, since the question is in terms of tangent, then we can make tangent here as the subject by taking 1 to the left hand side here, and we have tan square 2x should be the same as secant square 2x minus 1. I've just swapped it around. Now for that, we can use this one to replace our tangent from here. So let's go ahead and do that here immediately. So the integral of course, we need to write the first two ratios of secant 2x times tangent of the same angle 2x. Now this time our tangent is being replaced with secant. Now since there are also two terms here, we can go ahead and create a bracket And after that, we replace our tan² 2x by secant² 2x minus 1. So this is also with respect to x. Now at this stage, we can go ahead and substitute secant 2x with u, because its derivative will give us exactly what we had here. So the derivative of the inside function is the same as the function multiplying. So we can also go on and say, therefore our secant 2x should be equivalent to u. Now, when we differentiate secant with respect to x, what we get is secant 2x and tan of also 2x with respect to x equals to, and the derivative of u is 1 with respect to u. Now we're interested at making the x the subject from this equation, and we have dx equals to, of course we're dividing both sides by this coefficient, that is secant 2x times tangent of 2x. So since we've already gotten what is to replace our dx and also u that is going to replace this, let's move on to the next step and we recopy our first term also. So we have here secant of 2x tangent of also 2x, and this time we can bring in the substitution of u, and u should be squared because secant was also squared minus 1. So we multiply this with our dx, and we said dx was du over secant 2x times tangent of also 2x. So we can see here that secant 2x and tangent 2x can cross, and we are only left with the terms in u, that is the integral of, now let's maintain our brackets here. So we have integral of u square minus 1 with respect to u. Now this is straightforward, we can move on and integrate with respect to u, and the first one is 1/3 of u exponent 3 minus u plus the constant of integration. Now after that, we can make substitution, and at the same time we make conclusion. So we say, therefore, when we integrate secant with angle of 2x times tan to the 3rd power with the same angle 2x with respect to x, the result we'll get here is 1/3. So u is replaced by secant, and here is to the power of 3 of the same angle 2x plus the constant of integration. So that becomes our solution for the last question here. I hope you enjoyed the video, and if you do, leave a like, share with friends, and subscribe to the channel to get more juicy videos just like what we have watched right now here. See you in the next video where we shall be tackling integration by parts. Peace out.